So I think the important thing with somebody from a technical background when they decide they want to start a business is that there's no right answer. There's lots and lots of ways to doing business, and you really have to become comfortable with what you want to do with the product. So you have to keep testing, keep experimenting, keep talking, and the more people that you talk to, the more varied the advice you'll get. So don't just ask one person, ask a lot of people. There's a very strong program at the moment that the NSF is running called iCore, and a very important part of the iCore process is getting inventors to go out and ask people questions. So as part of going through the iCore, you actually have to go out and ask 100 potential customers for your technology. So that gives you an enormous amount of input, and it may help you work out that you're solving a problem that doesn't need to be solved. So nobody is interested in this piece of technology. It may be that you think you're solving one problem, but actually you're solving a bigger problem or a different problem for your users. So it's really important to really get out there and talk to people and get input. One of the things a lot of people are always a bit careful about is who they're talking to and what they're talking about. They don't want to let everybody know what they're doing. But if you don't go out and talk to people, you don't learn how to describe your technology and talk about the opportunity, but you also don't get what's most important is the input that helps you really shape the business that you want to grow. I think the most important thing that you need to do is get out of the lab, get off campus and start asking questions. Wherever you are, there's always a lot of people and a lot of resources around to really help you think through these issues. So it's not something that you have to do on your own. So just get out there, talk to people, and find the assistance programs that are there, you know, whether they're state, public, private, whatever. And the other thing is, buy people a cup of coffee. Attorneys, accountants, bankers, venture capitalists, angel investors. If you buy them a cup of coffee, they'll give you a lot of help, they'll give you a lot of leads, they'll really give you a lot of support. I think particularly in the US, but it's not just exclusively in the US, this is a culture that likes entrepreneurs, that wants to help entrepreneurs. And if you've got an interesting business idea, everybody is there to just really help you. So get out there, buy them coffee, seek their advice, and get going. So coming up with a business model or what the value add of your product is really fundamental. If people don't understand how you're going to make money in your business, then you're never going to get anybody excited about the business, and they're not going to, if they're not excited, then they're not going to invest. And that might not be money, that might be time, that might be relationships, it might be introductions to potential customers. So you've really got to show them that you've thought through how you're going to make money and how important that business is going to be in order to get them excited and interested and prepared to help you.
Okay, what do you think about the federal process through SBIR, which consists of first identifying and articulating the scientific or the research merit, then it goes to the second phase of connecting it to a viable business plan so that it comes out in market. So you have to work on two separate parts for reviewers to be convinced about it. Do you feel that's a correct way for scientists or people from universities to go about entrepreneurship as opposed to picking up like 5 books from a bookstore, no matter how good they are? So do you think that's a proven way to think through the process?
So the SBIR program has been incredibly successful. And it's an incredibly important source of funding for very early stage companies. It's, you know, crucial to a lot of growing companies. They get a lot of feedback. Certainly getting an SBIR phase 1 really helps you think through your proof of concept, but then a phase 2 can really accelerate where you're going. And it is true that working on the commercialization plan with your SBIR proposal is very important. When you go through the review phase, that's part of the review, and a very important part of the review, because if you've not thought about the commercialization, then you won't get funded. One of the things that is also important is that for external investors, if you can get some non-dilutive funding, so some government grants, they also see you as being smart, aggressive, and that somebody else has peer reviewed both your technology and your business. So that gives you more credibility and more help with raising money. Okay, so I'm Abby Barrow. I run the Mass Tech Transfer Center. I've been in Massachusetts about 13 years running that center, which is housed at UMass, but it's a center that works with all institutions in the state, public and private. So I work with Harvard and MIT, BU, Northeastern, Tufts, as well as all of the UMass campuses, of course, and especially some of the smaller colleges, Brandeis, Boston College, places like that. Before coming to Massachusetts, I worked in California, in San Diego, at UC San Diego, for 14 years. Initially with a program called Connect that helped to connect early stage companies with the resources that they needed to be success. So we used to call that the 3 M's, money, markets and management. I developed programs there, particularly programs that would help very early stage entrepreneurs think about what they were doing. And then I was very lucky, the School of Engineering there got a gift of $10 million to set up a commercialization center focused just in the School of Engineering. And my job was to set up that center and spend the $10 million. So we did that in a couple of ways. One, we developed some curriculum for engineering students, mainly for graduate students, on business, but this was entrepreneurial business and really helped them understand how entrepreneurial startups worked. We also developed early stage proof of concept awards. So these are small grants of money so we can get technical proof of concept. So it's just the very start of doing the D of R&D. All of the R is paid for by the big federal agencies, and we were just taking it a little bit to see if we could build a better prototype to show that the technology would actually work. So those were two of the big things that we set up there. So my job here, I work with everybody affiliated with universities and research hospitals and everything. So I can be working with an undergraduate student, I can be working with an emeritus professor. They've all had an invention, they all think that one of the opportunities could be to start a company around that invention. And I don't think the process is any different whether you're an undergraduate student or an emeritus faculty member. You still have to think through what's special about your technology, why people are going to buy it, what you need to show with it, and who you're going to surround yourself with to get out there and into the market. So particularly, and I think this is partly generational, the emeritus professor probably has had absolutely zero business training, probably no entrepreneurship training, and I think younger people, and certainly many of the postdocs that we come across now, have at least had some introduction to entrepreneurship. But it's really helping them frame what the business is going to look like. So what is the value of the product that you want to make? Who's the market? Who are you going to compete with? Why are people going to buy it versus what they're already doing? What do you need to show in order to get people interested in the technology? All of those questions. And quite often when you start asking these questions and people go away and process these questions, they come back or they don't come back because they've worked out that there isn't an adequate market for it. So it doesn't matter from my perspective whether you're going to set up a boutique sensor company that might only have 10 employees, or you're going to set up an enormous company that's going to need a lot of money. I don't care about that, but you need to find that you do have a market, that you've got a product that's going to make a difference and people are going to come in. So that's what we do, is really to help you think through those questions and really enable you to articulate what the business is that you're looking at. So most people, when they first come and meet with us, they talk a lot about the technology, about the research, about the discovery that they've made. By the time we've got to the end of our process with them, they're talking about who they're competing with, why the customers want it, how big the market is, how it's going to change everything, how much money they need, what milestones they need to make, all of those kinds of parameters about the business rather than the actual technology itself. So tech transfer really started as a main university practice in the early 80s. Universities have always worked with industry around them, they've always commercialized technologies. But really in the early 80s there was an act called Bayh-Dole that really leveled the playing field for everybody and mandated that universities really look at commercializing and transferring the technology they were developing. So that's a very important legislation that rules what the Tech Transfer Office does. What it says is that if the federal government funds the technology at a university with the permission of the agency that funded it, the university can take title to that technology. So every time the university hires a graduate student, a postdoc, a technician, a faculty member, they all assign any inventions that they make during their work at the university to the university. So if you're a faculty member, if you're a postdoc, the university is paying you. Anything that you invent on the job belongs to the university. So you have to disclose any invention you make to the university, and then the university decides whether they want to apply for a patent for that technology or not. You can, of course, just put the technology out there. If you don't want it patented, you can publicly disclose it. That's a right that faculty members have or researchers have. But if people are going to make money, if it's going to be patented, then you have to disclose it. Once you've disclosed a technology to the university, talk to the federal agency to get permission to take title to it. And then if they decide to patent it, they'll also hire a patent attorney. And then they will work with you. It will review the technology with the agency that funded it to make sure that they're okay with them taking title to it. That's a bureaucratic process, but it does still have to be done. And then they'll really work with you on whether the technology is something that should be licensed to an existing company or to a startup. Of the technologies, be they postdocs or grad students or faculty members, that they want to do. So then when the technology is ready to go out, there will be a license agreement that is signed. So that's a formal legal document that enables whoever is licensing the technology to use that patent. It's usually restricted on markets, specific industry sectors, specific geographies, and you pay for that privilege. So there's usually a royalty stream attached, there may be an annual fee. So they're quite technical legal documents. You need to get outside advice when you start putting together a final licensing agreement. But that's the sort of fundamentals of tech transfer. Of course, what everybody hopes is that you'll go out, you'll commercialize the technology, you'll start selling it, and then the royalties will start flowing back to the university from that invention.